So let's do a couple of initial value problems. So before we start, I want to remind you, when we are finding antiderivatives, right, if we integrate y prime of x dx, right, what we get out is y plus c. Right, so if we integrate the derivative, what we get out is the original function plus that constant. So what an initial value problem does is it gives us some sort of initial condition that lets us find the value for c. So here's an example. If y prime equals 2x plus 1, so we know the derivative, we know the rate of change, and we also know the function value at 0 equals 4, we can find y of x. So here we go. So first thing we do is we integrate y prime dx. So we'll use our rules that we know. So power rule for the 2x. So 2x squared divided by the new power. So add 1 divided by the new. Integrate 1. That'll be 1x over 1. Right? And then we have our plus c. So I'm going to go ahead and tidy that up. So now we know that y of x equals x squared plus x plus c. Now when we grab our initial condition, we can find out what c is. So if x is 0, y is 4. So I'll put a 4 in for my y, a 0 in for my x's, and that tells us that c is equal to 4. So we know that our function is equal to x squared plus x plus 4. This is the function that has 2x plus 1 as its derivative and the initial condition of y of 0 equals 4. Okay, let's do one more. So this time my derivative is sine 2x, and my initial condition is y of pi sixths equals 1, and we need to find y of x. So again, here's our derivative. So to find the function, we integrate, right? We find the antiderivative. So integrate sine 2x dx. Remember, dx non-negotiable. And either do it with a u sub if you've learned that, or just the property if you haven't, right? I've got this k coefficient in there, so it's 1 over k on the outside, so 1/2. And then sine, my little cheat sheet again, integrate sine, we get to negative cosine, so negative cosine 2x, argument stays the same, plus c, right? So I have my function family so far. Y of x equals negative 1/2 times cosine 2x plus c, and now we'll use that initial condition to find out what c is. So x is pi sixths and y is 1, so 1 equals negative 1/2 cosine of 2 times pi sixths plus c. So 1 equals negative 1/2 times, what do we have in there? Pi thirds, cosine of pi thirds. Gosh, I'm showing you all my little cheats. So pi thirds is the tall one, and the cosine's the short one. That makes that a 1/2 plus c. So 1 equals negative 1/4 plus c. It looks like c is equal to 5/4. There's my arithmetic. So altogether then, my function y of x equals negative 1/2 cosine 2x plus 5/4. This is the function that has sine 2x as its derivative and the initial condition of y of pi sixths equals 1.